Hello everyone, welcome back to Homeport. So we're going to have another demonstration today with echo.1, joined by Ollie Anders from the team. Before we jump into it, just a brief introduction. So echo.1 is the first unmanned surface vehicle officially approved by the Waterway Police Authority for the acquisition of hydrographic data in the Hamburg port area. Besides its underwater surveying capabilities via multi-beam echo sounder, it can scan terrestrial structures above water as well as with a laser scanner. So to talk us through the presentation, Ollie will go ahead, and over to you.
Thanks, Louis. So I'm Oliver Anders, team of the Hydrographic Survey Department in the Hamburg Port Authority. The Port Authority is responsible to maintain the water depths in the port, and that's what our department is doing. So Hamburg is a tide influenced port, which means between low tide and high tide there's a height difference of 3.3 meters to 2.80 meters. And this means with every tidal current, sedimentation is coming into the port. This is sand, this is mud, and this settles in the area, in the shallower areas. So the depths at the jetties is changing more or less every day. To guarantee a safe depth, a safe nautical clearance depths, we need to survey the jetties every day, nearly every day. And therefore we have several survey vessels. We have 4 survey vessels in the port who cruising around every day. And with the time, you see these autonomous systems arising. And we, as a port authority, wanted to keep a hand on it. So we bought this system for around 2 years ago. And this little guy helps us with the big survey vessels to maintain the depth. So let's have a look at the system. This is an autonomous surface vehicle. It's not going on underwater. It's cruising above water. And we have several sensors on it. So we have 2 GNSS antennas, which give us the position of the system. And underneath, there's a multi-beam echo sounder. This will scan the depths until the surface of the seabed. And above, there's a laser scanner, which is not seen on this demo. It's on the vessel which is currently sailing outside, where we can scan the all above terrestrial. Furthermore, we have a camera which we can pan and zoom and tilt to have a first-person view of the vehicle. And to communicate with the vessel, we have a Wi-Fi antenna to have a direct connection, a direct Wi-Fi connection. And as the backup, there are several cellular antennas. So we use every 3 operators, which is Telecom, Vodafone, and O2 together. So if there's a outage in one cellular network, we automatically switch to the next one. Furthermore, we have all this standard shipping equipment, which means we have an automatic identification system, which sends the position and the name of the boat to all other vessels that they can recognize us and talk to us. So they see our name of echo.1 or echo.x on their screen, and we have a direct VHF connection, which is responded by an operator sitting somewhere else. So the operator can be anywhere, theoretically, it's easier to have the operator close to the survey or to the survey area, or the survey system. But because we are independent of the location, he can be in the office or somewhere else on the world. This is shown here, right next to me. So basically the control station is just a notebook where we see everything of the vessel system. And I guess we switch to the vessel in the water. So we hop over from the demonstrator object to the vessel in the water, which is currently surveying or just hovering at a so-called home point. So if we have a look on the screen, my colleague Tjerk just prepared a route which we want to survey right now. So we can start the mission, and echo.1 will follow the route by itself. So Tjerk, you can let it go.
Fährkanal ist frei, hier auf Automodus. Okay.
So now the system is started. We start surveying. This means on the left screen we see the colorful picture which is showing us the depth information. The green area is deeper areas, and where it's coming yellowish or red, it's shallow. And following its route, the depth information is stored in the database and shown on a grid. Then on the screen on the right side, we have the first-person camera, which is showing us the front view, the first-person view. And now this is the depth information we see. Now we can switch over to another layer, which is showing us the terrestrial information. So it's scanning everything which is above the water. You see there are piles or jetties under the other boats. Mainly we use this terrestrial information to have a better overview of the area, because we just have information of the other system, of the other vessels which are there, but any objects like dolphins, jetties, boats which have no information system, we don't see by any service which is provided, so we scan it by ourselves. And which can be used by the collision avoidance system as well. So if we have a look on the right side on the screen, we see some radar points. These are red dots which show up at some time. This is direct collision avoidance information. So the boat will follow its line, and if there's an information that there's an obstacle in front of the system, it will give us the information that there's something. And the level of autonomy is right now that we, as operator, need to choose what to do now. The boat is just giving us the information and is stopping, and we need to do the action afterwards. And that's what we want to improve in the future, to have a collision avoidance more automated. So this mission is now finished. Normally it's a larger area and more stuff is surveyed, but then all this data is sent to the office. It's going into a database and then can directly be used by any customers in the office, in-house, or from external clients. The turnaround time from job finished to have it in the database where it can access is around 2 hours. Job finished, 2 hours later, everybody can use the data. And this is not a demo. This is in operation since 1.5 years now. So normally we have this little guy here on the back deck of one of our bigger survey vessels. We just deploy it. It does its job at the big vessel. And we combine the data of the main survey vessel as a mother vessel, and this guy here with the autonomous vessel is one big data set, and everything can be used together. So it's used as a force multiplier, same person on board, but much more efficiency.
Thanks, Oliver. So I'm wondering, I can see here Kongsberg is written on the vehicle, and there's a number of other vehicles around. Can you maybe talk to us a bit about the partnerships you have in place in order to sort of facilitate this? The partnerships.
Yeah, okay. The partnerships are, so we are just the surveyors or the technical division in the port to gather the depth information. Normally we use the big survey vessels. But to get in touch with the autonomous systems, we had the partner Ocean Alpha. That's just the boat itself with all the steering and engine parts, like the radar, engine, antennas. But all the survey equipment, this is done via Kongsberg. Kongsberg is a supplier of the multi-beam, every subsea sensors, and they integrate everything quite fine. I don't know if we can have, with this camera, a look inside. I guess not.
So what are we seeing here?
So we have, because the boat is moving quite much, we need an inertial sensor, a motion sensor. This is a little guy, a normal processing PC. The multi-beam, which is mounted under it, coming out here. The AIS system, which is here. So to transmit their own position and receive the position of the other vessels.
And in terms of the connectivity, as you mentioned, there's the number of different antennas and stuff to ensure a strong connection. Can you just explain a bit about how that works and if you lose connection with one and then it switches over?
Okay, previously I said we use all 3 big players on the cellular market in Germany, which is Telekom or to Vodafone. And I said before that we use one connection which is then switched over to another one. That's not the correct way, so we tried to do it to streamline. So we have every information from every network provider on one channel, and we check for the smallest latency which is available, and all the data is sent to every channel, and then bundled via a VPN connection to our control center, and then split it there again.
So it's really to have redundancies in case,
Yes.
right? So you can be as efficient as possible. Okay. And then I can see here we've got some other vessels here, and then we've got I'm assuming this is around life-saving. I mean, are these part of the same system, or is it always going to be this one? How do they fit?
So we had a demonstration about 3 years ago. We invited bigger autonomous vessels, smaller ones, and we, as Hamburg Port Authority, found out that this size is right now the best size, which is handleable. You need much more logistics if you get bigger boats. And that's what we found out, that this is the right size for now. You can handle it with 2 persons. It's around 60 kilos now. You can just throw it in the water by throwing in the water. That's not the main discussion, but this guy here on the right, it's called the Dolphin. Another one, this is a life-saving boy, just because you pointed to that one. That's the one you can just throw in the water, and this is not autonomous, it's just remote control, life-saving, like you would normally throw a life buoy inside if somebody is there. So the person in the water needs to grab it, and then you can bring him back to the jetty.
So that will be stored on ships or on shore?
Both, like everywhere where normally people fall in the water.
Okay. All right. And then if we're talking about, so Homeport is a facility that aims to trial new technologies, you know, in the air, but also surface vessels and underwater. I'd just be interested to hear, given this is the sort of start of Homeport, how you see maybe sort of the echo.1 and the work you're doing integrating into sort of the Homeport operations moving forward. What are you going to test?
Yeah, that's a big question, because we need to have all the regulationary stuff ready before you start here in such a big port. It's not a lake, it's some other ships are coming, it's a very busy port. So we wanted to have such a system by ourselves here to know exactly what the software is right now capable to do, what level of autonomy can be trusted, or what kind of regulations we need to give to other persons coming here with their systems that we have. Our idea is to have like a certification or a license, whatever, to say, okay, we know what you have implemented in your software, and that's what you need to have to do your surveys here in our port.
Okay. And I'm wondering, so in terms of like the range, I guess, for the battery, but also the connectivity, I mean, how far away can this go? How long could it be in operation before you need to change out the battery or charge it?
So it's electrical powered. There are 2 batteries inside, which will last for about 6 hours. Our normal survey speed is 5 to 6 knots, which means at 6 hours just operational time, it's for us not a normal survey day. And then we need to come alongside shore or to the mother vessel to change the batteries, which will last 10 minutes, and then it can do another 6 hours again.
And in terms of the applications, so we were hearing from some other demonstrators earlier around the need for sort of real-time surveys for ships coming in from offshore. Is that, in terms of the actual specific use case for this, is this kind of a more ongoing routine survey, or is it also on demand?
The on-demand survey is not what we at an authority want to have, because we want to guarantee the data. So we know our system, a trusted survey. So that means we do the routine jobs, and that's what we at the authority give out to our customers. Just throw in a drone which does some survey and then comes back. Or
Okay, I understand. And then kind of looking ahead in terms of what additional technology you would maybe include in this down the line. Do you have any ideas in terms of, I guess, other sensors or way of interpreting the data? Yeah, can you talk to that at all?
so right now the payload is the limit which we reached right now. So with the multi-beam and every other systems, we cannot add any more to it right now. But it would easily be to add more sensors if we have a bigger vessel. So there are so-called ADCP, acoustic Doppler velocity sounders, which measure the current of the water. That's another typical job which is done by port authorities. But we could interchange the sensors or just try to get a bigger boat and add everything which is possible.
And maybe this is not public information, but I'm just interested, how much is the cost of kind of one of these hardware setups?
I guess you need to ask by yourself to the suppliers.
Okay.
It's cheaper than a regular survey vessel.
Yeah, exactly. And there's less personnel costs and maintenance, I guess, right, than keeping a full boat in the water.
I guess I have one more video which is called, I named it Cloud Compare. Maybe they can show it on the screen, which is showing the result of a bigger survey, which was done with echo.1. So,
Here we go.
yes, here you see the port with all the depth information, not just as a small scale, which we have done here. It's on a bigger scale. And that's the result. The 3D information, a 3D point cloud.
And how long has it taken to put all this together?
This was done in 8 hours.
The entire...
Yes.
Wow. If you could do it in 8 hours, how often do you have to do it then to update it?
Every 2 weeks. But then not just with the vessel, not just with this small one. We do it in combination with the regular survey vessel, and that's the second video we have. It's called Megaswas. That's what we try to do more often. So we have a mother vessel, which then deploys this echo.1, and then they do both the same area. So on the screen you see now our regular survey vessel, which is found on the left corner, and echo.1 is following in a specific distance. And they both do the same survey, and we can combine the data.
Would you foresee a point where echo.1 is the sole survey sort of hardware? I mean, would you see the traditional vessel being replaced eventually by echo.1, or a sort of fleet of them?
That would be possible, for sure. But right now, at the moment, we are not at the point to have so much trained personnel for autonomous systems. It's not easy to get this change, and I guess we don't want to do it. And there's another limit, because the physical, technical size which you can mount on the vessel is at the moment not possible with the small ones here. You need bigger vessels to have the echo sounders installed.
I see. Wrap up. Okay then. So I think that's most of the questions I had. There is, of course, a previous recording of the previous session we did, where there was other questions being asked. So with that, we'll wrap up this session. echo.1 are here for the rest of the week. You can find them in the container at Homeport. And Ollie, I think, will be giving other demonstrations throughout the week as well. So thank you very much, Ollie, and we'll say goodbye for now.
Thanks, Louis.
convert